Let's say you want to buy Elegoo PETG because it is cheap. The price is the same, but which one would you choose? PETG Pro or Rapid PETG? And this is what I would like to answer in this video. Hello, welcome back. Recently I got some comments that probably I hate Elegoo because I never presented their filaments on my channel, but they are super cheap. It's not true, I just never had the opportunity for this. And recently I contacted Elegoo if they want to send me all their filament types because I want to present them all on my channel. It's quite confusing, they have many PLA and PETG types, and their answer was they can send me 3 or 4 filaments. Okay, never mind, I told them I'm buying them myself, and I bought every PLA and PETG and even ASA type, all in red color if it was available in this color, of course. And exactly for this kind of purposes, I have the budget from the Polymaker, who became a channel sponsor. And this is huge advantage because I don't have to wait for the company if they want to send me the filament for the testing or not. I can just buy anything I want to test. For this video, I am presenting their 2 PETG filaments because one filament I'm still waiting for, and that's the carbon fiber PLA, and then I can present all PLA types in a separate video. And a small correction. This is the website which I recorded when I started with the intro, and this is the website one day later. This means in this video I'm not testing all their PETG filaments, only those without fiber reinforcement. Now let's talk more about these PETG filaments. In both cases the price is around 14 euros per kilogram, which is super cheap, especially here in Europe. About PETG Pro, comparison to PLA, it is durable, impact resistant, which is weird. It is not always the case comparison between PLA and PETG. Chemical and water resistant, correct, my experience definitely, and easier to print than ABS. Sensitive to moisture, which is true for both filaments, for every PETG filament actually, we will see the reduction in the print quality. Now about Rapid PETG. It has the same base like PETG Pro, but it has improved flowability for high-speed printing. So this means I cannot really use the same G-code in both cases. Here I will try to increase the speed a little bit, or maybe I will do some layer adhesion tests on different speeds for both groups. For the drying, they recommend 70 degrees Celsius plus minus 5, which is a little bit weird. Usually for the PETG I go up to 60 or 65 degrees Celsius. Maybe it is more temperature resistant, we will see soon in this video. About print settings, for the PETG Pro between 230 and 260 degrees Celsius. For Rapid PETG it's a little bit higher, between 240 and 270 degrees Celsius. And we can see big difference in the recommended max speed for the PETG Pro up to 270 millimeters per second, and for the Rapid PETG up to 600 millimeters per second. This is huge improvement. I can see the main question for this video. Since the price is the same, is there any advantage of the PETG Pro? Watching the specifications on the website, the mechanical properties are extremely similar, but a Rapid PETG we can print on much higher speeds. In my experience, probably with the Rapid PETG we can expect more oozing or stringing. It is more sensitive to moisture, but I'm just guessing and I don't want to talk without measuring or testing. We will get back to this question at the end of the video. Time for unboxing. They both arrive on the cardboard spool. First I thought that this is plastic, but then I can see here that it is cardboard. And I'm not sure if I understand correctly this sentence on the website. Then they have hardened edges and they can go into the AMS unit. Now on the Rapid PETG, on the sticker I can see recommended print temperatures are different from those given on the website. Between 230 and 260 degrees Celsius, same like for the PETG Pro. But as I mentioned on the website, they are a little bit higher. On the spool, I really like this ruler, only here it is hardly visible because it is in white color. We can see approximately how much filament we have on the spool, but what I'm missing here, what is the weight of the empty spool? I will start the printing out of the box without drying, and I'm starting with the temperature tower in both cases, and I will see some bigger stringing. In that case, after the temperature tower, they are going to the filament dryer, and only then I will print my test objects. Both filaments I'm placing into the AMS unit. Theoretically they have the hardened edges, so they shouldn't cause the problems here. And the printing will be on the P1P, which is open style printer. The first temperature tower, starting from 270 degrees Celsius. Overhangs are okay on any element, only I can see more stringing on 270 degrees Celsius. Maybe outer loops had some moisture in it, but it will get some drying and then I will reprint this one element. It will be a short drying on 65 degrees Celsius. Usually for the PETG I use 60, but here I can rotate the spool during the drying, so I set it to 65. And in the meantime I am printing the tower with the PETG Pro using the same G-code, even if it is above the recommended print temperature range. And as I predicted, this one is less sensitive to moisture, so it looks okay even on 270 degrees Celsius. But the test objects I will print on 260, which is the maximum recommended print temperature. And again, those overhangs looks nice, only I'm not too happy with this bridging, so this filament goes to the filament dryer too. Printing is finished a few seconds ago and perfect printing, 270 degrees Celsius. I hope it's visible on the screen too, so perfect printing now on 270 degrees Celsius. So with the PETG the drying is important, especially with this high speed or rapid PETG. Looks much cleaner. This is the element at 260 degrees Celsius because this will be the print temperature too. It started with the bridging. And now I know my print settings. For the PETG Pro, 260 will be the maximal temperature, 12 will be the max flow rate, and cooling I reduced to maximal 80%. And the only difference for the rapid PETG that the print temperature will be 270 degrees Celsius and the maximal flow rate will be 16. Everything else is the same. It will be finished soon. I can see a few strings here and there, but very minimally. PETG Pro. Absolutely zero stringing. They are labeled ready for mechanical testing. And one thing I want to mention here, rapid PETG sticks almost too good to this textured PI sheet, so be careful when you are removing the object or use some separation layer like glue stick or similar. Tensile test with horizontal printed objects. This is average from 2. And now rapid PETG. The advantages on the rapid PETG side, difference is nice but not so significant, only 9%. Layer adhesion test with vertically printed objects. Rapid PETG. These are good values. Now this difference is significant, and I believe that this will be one of the main advantages of the rapid PETG. Flowability is better and layers should bond better to each other. But before I continue my classical tests, I want to investigate this a little bit deeper. Another layer adhesion test, but printed on different speeds. For the rapid PETG it will be 200 mm per second. For PETG Pro it will be 100. And more or less I should get similar layer adhesion if I calculate it correctly. D12 dice is here just to avoid slowing down because of the minimal layer printing time. Printing was completely okay in both cases. Let's see the numbers. This is PETG Pro, average from 2, and now rapid PETG printed faster, again average from 2. So even if it was printed faster, the layer adhesion of the rapid PETG was slightly better compared to the PETG Pro. Shear test, side by side two materials. These are printed in horizontal position, and now printed in vertical position. When printed in horizontal position, in this test the difference is negligible. Now printed vertically, the layer adhesion is very important, and here again the advantage is on the rapid PETG side. Torsion test, side by side two materials. These are printed in horizontal position, loaded 90-degree rotation, and the maximum load.
1.2.
And these are printed in vertical position, same dimensions.
1.
Nice break on rapid PETG, not along the one layer. This is a sign of the good layer adhesion. In both cases the rapid PETG was stronger, but the difference is not big. And maybe one interesting information here, with horizontal object with the PETG Pro I could make more than one turn. Maybe this is important to someone. Impact test PETG Pro. Zero position. Rapid PETG. This is the zero position of the hammer. And this is the edge position after breaking the PETG Pro, and this is after the rapid PETG. This time the PETG Pro was stronger a little bit, but the difference is not significant, And don't be confused with the specifications given on their website. These numbers are much bigger, and probably the reason for this that they use the Sharpie impact testing method, which has the support on two sides, and with this the measured values are higher. So with my new equipment I will be able to measure both methods. 3-point bending test. Distance between supports is 50 mm, and I'm measuring the deformation after 1, 30 and 60 seconds. This is the deformation under 5 kilograms. And this is under 10 kilograms, and very minimal additional deformation during this 1 minute. Smaller values are better, less deformation, and here the rapid PETG is again better, but what is interesting to notice, under 10 kilograms we have less deformation during the time compared to the PETG Pro. This is some kind of creeping, but I have a whole separate test for this. Creep test the deformation under the constant load. This is PETG Pro and this is rapid PETG. 18.01, 16.74, so a little bit more deformation on PETG Pro. The last 5th day, let's measure them again. 20.18, 19.12. Removing the load. And their permanent deformation is very similar. On this graph we can see the deformation distance between two reference surfaces, and we can see less deformation on the rapid PETG. But the creeping is the difference between 2 days, and that's what we can see on the second graph. And more or less we can see some difference here, but I would say that these are very similar for the creeping. Temperature test in the oven, M10 nut as a small load. And I started with deformation on 65 and 68 degrees Celsius. I stopped the experiment on 97 approximately, and of course they are very soft at this temperature, but think twice before you start drying on 70 plus minus 5 degrees Celsius as suggested. All results one more time without any additional comments, and these 2 lines will be added to the summary table for my Patreon supporters. Results for the layer adhesion test, shear test, bending test, deformation after 30 seconds, bending test, deformation after 1, 30 and 60 seconds, torsion test, impact test, and the temperature test. So the price is the same, and I cannot really see any advantage of the PETG Pro compared to the rapid PETG. However, we will see better layer adhesion and we can print on higher speeds too. So only smaller disadvantage I can see of the rapid PETG. First, that we must be careful, the filament must be perfectly dry, otherwise we may experience a little bit more stringing and oozing from the nozzle. On the other side, also it may stick too good to those very popular golden textured PI sheets. For these purposes actually I have that black one which I got with the P1P, and it is much better for these copolyesters because it sticks good to it, but when it cools down it is very easy to remove it. So if you use this rapid PETG with that golden textured PI sheet, use some glue stick or some separation layer just in case. And huge thanks to all my Patreon supporters, because with their donations and with sponsoring by the polymaker, I can now buy any filament I want to test. You can see I paid for these filaments approximately $180 together with the PLA. It will be tested in a separate video. And to all you others, well, thank you for watching this video, and happy printing!